So why are we here? So why is analytics important for the process industries? And there's some fundamental things that we think have shifted in the market. So as an analyst, we get exposed to a lot of different oil and gas companies and chemical industries. So we learn about some of your challenges, and we talk to a lot of folks that are making some really cool technology. Last year, when we started studying machine learning and predictive analytics, the number of suppliers that have emerged were in the thousands. Okay, so there's a lot of dynamics that are happening today, but basically what we're finding is it's getting easier and easier to collect data. An example that I have here on the slide is a bearing a bearing monitor from SKF that's got some built-in technologies, and the technologies are getting so small and compact and easy to configure with your systems that you don't need much of the complexity of the systems of yesterday. And we know ultimately that certain industries, especially the aviation industry, has done a great job of making it, changing the way that we do maintenance in that particular industry. So in this case, I've got this would be a GE turbine, and we understand a little bit about how they do the maintenance and collect information. So one of the most important connected assets we know is actually one that's up in the sky. So what we see is happening is because it's easy to collect data and it's getting much simpler, we've seen the emergence of something called IoT or analytics platform. So this is the way that ARC would present this, and we understand that many companies are building very unique ways to ingest many different data sources. And the data sources that I think of in the process industries are the things like all of your historian archives. It could be your operator logs. It could be your incident management system. It could be data relative to the operator training and things that are happening. So a lot of this data is getting easier and easier with new platforms to ingest this data. So what we see ultimately, and because we know that data in the process is it's very unclean, and much of the data is erroneous. So we know that many of the suppliers and the solutions are really good at cleansing the data and bringing this into systems that owner operators and users can easily make sense of the data. But before I get going, I want to talk about. This is a movie that I saw recently. How many people have seen 2001: A Space Odyssey? Excellent. Okay, that's right. This is really good because this is sort of fundamental to my talk here. But I want to introduce the persona on the left here is Dave Bowman. Okay, so in Stanley Kubrick's movie, The Space Odyssey, so he was the astronaut. He was kind of the guy in charge, and he was a subject matter expert, and he's kind of like today's operator or tomorrow's operator. And on the right-hand side, you have this thing called HAL, and HAL in the movie was a autonomous computer capable of natural language recognition and could interact with the astronauts in space. So I think what's happened here is that Stanley Kubrick in Hollywood back in 1968, they actually came up with something very profound about the way maintenance and operations should be carried out. So I'm going to play a little clip of a video, and then I'm going to talk about some of the things that we see industry relative to that clip. So just bear with me. This is only 1 minute in length. And I think we need some sound. So basically what's happening here is the computer has identified a fault with a very critical piece of equipment on the spacecraft called the AE-35 unit. So there's a dialogue that's taking place right now between a computer and a human is interpreting what's happening. And since we don't have any sound, I don't think we're going to get it. I'm just going to flip to the dialogue here. So basically what happens is Hal basically says, I've got a fault. Okay, but what really happened, right? So the artificial intelligence or the analytics basically identifies a problem and probably wasn't a threshold monitoring, so it wasn't a condition-based monitoring thing. So basically the computer, we know, is looking at multivariate data and machine learning, so not a threshold alert, right? So the human says, or the subject matter expert, is it still within operating limits? And basically he wants to understand, I'm operating this craft, could be a facility, what is my risk? Is there something I can do to change my operation? So Computer has identified fault. Immediately, human doesn't immediately react. The human actually does a little bit more interrogation. But further, what happens is the AI, HAL 9000 in this case, says, yes, so we confirm that we're within operational limits, and HAL basically says, yes, it'll stay that way until it fails. Right, so there's further interrogation of the information that's on board with additional on-premise information. But one of the key points here that Stanley Kubrick brings forward is the human says, do I have a reliable 72 hours? So this is not an immediate failure, because of course you wouldn't want to have an immediate failure on a system. There's an exchange between human and computer to quantify or a probability of failure on this piece of equipment. So this is the most important aspect of analytics that I'm going to talk about in this presentation, because we're dealing with probabilities and lots of data, not on single threshold where it's too late and the AE35 unit has gone offline. So the next thing that happens is, now that we've had this exchange, there's a new work process that gets implemented on this spacecraft. And this work process is not a replacement work process that you might have with an EAM system or a CMMS process or something that would invoke maintenance. In this case, the subject matter expert, the astronaut says, I'm going to enact a performance analysis process, and I'm going to do a little bit of digging to see if there's something I can change in the way I'm running this ship to keep this thing from failing. So the AE35 unit just happens to be the main communication back to central control. So all this dialogue happens in about a couple of hours in movie time, and there's an analysis and looking at models, and ultimately they decide that there's nothing they can change with the operation. It's time to fix the piece of equipment. So that's the video that you didn't get to see. So why do I think that's important? Because I think that's important because, at least in this industry, historically, most of the maintenance and most of the cost has been spent on break-fix maintenance. So we would see, this is our ARC's maturity model for asset performance management, and we would say that, I would say my guess as an analyst is probably closer 1% to 2% of all maintenance has been predicted with the tools they have. So what happens is there's new tools, new platforms, new sensors that are allowing companies to take advantage of analytics. So if you look at the sort of the bottom from the condition-based down, the threshold-based monitoring technologies, they've been around for a while. They work, they have the valid purpose. But what we're seeing is that the analytics is applicable to the top two, which would be the predictive, the PDM, and the prescriptive. Because ultimately, we see that the solutions as being a lot more sophisticated, and not only can they diagnose root cause, but they can actually provide prescriptive advice on how to change the outcome. So this might be a little bit different from some of the things that you're seeing in the industry today. So looking at it from another perspective, we think that operationally in the process industries, what we're doing here is we're trying to predict failure points. So when I think about assets in the process industries, I'm thinking about exchangers, batch processes, reactors. This could be centrifugal pumps, axial compressors, all these things that are critical to the process that tend to be operated and maintained in separate silos in a very reactive manner. So what analytics we see doing is if you look at the asset performance curve, what we're seeing is that companies who are successful in using this are not waiting for actual process degradation or operational failures and suffering downtime in their facilities. They're actually using the tools and empowering the workers with these processes that I described as process improvement workflows to actually do more detection earlier. So some of the clients might be looking at detection of, say, 90 days or 6 months in advance. So the companies are using the right data to actually look at the triggers that are happening actually weeks and months in advance, and possibly changing the operation and preventing the actual degradation from occurring. So basically we look at everything on the right-hand side. This is all condition-based monitoring. Everything on the left is analytics. These are some other statistics that have been floated around for a long time. UAL, the US Navy, they've done lots of great studies. But one of the things we see when we look at assets is most of the data is based on perfect conditions, done in the lab, and they're actually done and they're not, the testing is not done in actually the way that they're operated. So we find that because operations is sometimes there's a lot of variability, the process flows can vary quite a bit. Sometimes the assets don't actually perform as expected. So basically these studies have said that over 80% of all the failures tend to be random. So fast forward and looking at analytics, go back one, sorry. The question is what's really causing those random failures? So the companies that have embarked on these pilots and programs, they're finding markers, going back to that performance curve, they're actually detecting when the assets will fail in advance. And they're not just looking at the information that comes off the rotating equipment or the discrete device. They're actually looking at the data that's around it. So some people talk about big data or tiny data. There are aspects of analytics to look more holistically at the things that impact the assets. I had the opportunity to meet with Martin Hawkins. He's the COO of HMEL. They're a refiner based in Southeast Asia. And this is just an example of some of the financial benefits that they see in their strategy. By the way, this conference was last October. It was all about analytics. So everybody in that region they feel as though their organizations are ready. Everybody was talking about this technology. So basically, it's maintenance budgets, it's operations budget, it's increasing availability. But ultimately, he looked at this from two sides. One, reducing total operations and maintenance costs, and also improving operations performance. Sometimes, I speak about industrial Internet of Things and analytics, and there's a tendency to think that we've been doing this for many, many years. What's new? We've been connecting devices. But actually what we find is when we talk to customers is that most of this data has already been collected and has been sitting dormant within the various disparate systems, whether it's a process historian. And there's a lot of effort goes, of course, to mining that data, applying that context by people that understand the process of the assets to make determination. So what we see is we would say that this is an application of machine learning. So the people that are spending all of the time contextualizing this data, the machine learning and the analytics is actually automating that to produce the results they need and the outcomes for their particular industry. So another question that we often get is about the engineers and about the staff and the erosion of the workforce. So your engineers that understand this context and they know which tags and which trend, and they know what happened the last time they overpressured a vessel or the last time they did flaring. There's people that understand all of that. So companies are starting to look at how to capture that data and the things that they did naturally with historian data and other systems and the workflows that were built in. It's capturing that information and making it available in systems for the next generation of workers that coming in, because most clients that we talk to, erosion of workforce is definitely a serious issue. This is yesterday's technology. We've had great dashboards, and they've worked very well. But I think most customers would say that they've had difficulties getting access to the data, and it's been very, very difficult. A lot of these systems are maintained by IT shops, and they don't have context, and they're not in enough time. So this is where we've been with the technology. Those of you that may have attended our workshop on analytics selection yesterday, Mike Guilfoyle presented this. So this is the way that we would see the market. And we're not saying you don't want to do everything prescriptive or you don't want to predict everything, but there are certain assets that you will turn to predictive strategies, but there's also assets that you will do break fix, and certainly dashboards and what we call performance analytics would be adequate. So on the left-hand side, the category of suppliers are more threshold-based and based on performance. Basically, we would say that those are important for decisions that are reactive. Usually there's some damage done, but you're averting a crisis. But if we look to the newer breed of technologies with analytics and machine learning, this is more like what is likely to happen. It's dealing with structured and unstructured data. There's sandbox environments, so folks can do their own development and look for problems that they didn't know that they had. But what they're trying to do ultimately is avoid the damage and avoid the crisis. So this is about further reducing cost. And most of the suppliers that we see that are doing interesting things with machine learning and the technologies are more on the predictive side. It's still a little bit new on the prescriptive side, and it's definitely most of the solutions are not closed loop. They're informing a human. So just as Stanley Kubrick depicted, the computer is detecting the problem and informing the subject matter expert, so the subject matter expert can remedy the activity. So this is, we know that there are different types of machine learning in predictive and prescriptive analytics. This is a bit related to data mining. This is, there's supervised and unsupervised, and there's also deep learning is another form of machine learning. The other interesting dynamic in the question that we get asked, because with complexity of data and new platforms and new systems, is how are we going to ready our workforce? So some of the folks that are behind the scenes, you often hear about data scientists. So this is how we would see a data scientist, and they're not prevalent, they're not common in industry, and they're certainly not common in oil and gas or other process industries. But they may be curious about data, like your engineers, but they're trained with a particular set of tools that your process engineers tend to not get trained on. So most engineers use simulation tools. They use Excel, XY plots, some statistical and some basic modeling tools. But most engineers in the process are not trained on things like statistical computing, MapReduce concepts, distributed computing. So excuse me, these are all skills that come along with this data scientist. So we would see, as we move forward with predictive analytics or prescriptive analytics, the data scientist has got to be part of the solution in some way. So that's either with the technology supplier or it's built into the solution to make it easy, because we don't see every oil and gas or chemical company is going to start hiring a bunch of data scientists to do the work. And in terms of opportunities for predictive analytics or machine learning, really the sky's the limit. There's so many clients that we talk to that are doing proof of concepts in different areas, and it's not just about preventing machines from breaking down, like machines that spin. It's detecting when incidents, or looking for the markers that can detect when you're going to flood columns, or whether you might cause a process upset or something like that. Because oftentimes the process, the way the processes work is they don't. Sometimes it's not on/off. Sometimes the process is just degraded because of a problem. It could be foaming or fouling of different systems. So it's looking for those things using the tools that you didn't have before. So it could be process quality. It could be on the back end, on the things that face the customer, and ultimately dealing with process variability. So there's some really important things, and as we continue to research the subject, we find many cases where customers are finding evidence of benefits with predictive analytics. And that's just, if you want more information, those of you that follow our blogs, industrial-iot.com is one source where we're continually writing case studies or putting information out. Or just go to arcweb.com, manufacturing operation technology, and this is all available on your mobile device. So I encourage you all to go to these sites to continue to follow what we're writing about analytics.